Disclaimer. Listeners, please be aware that this article is for information purpose and may not in a whole holds the final facts or figures concerning this article upon this subject matter. Everyone is strongly advised to carry out their own research into the subject before making a final decision about this article. We are not responsible for any loss or damage you may suffer as a result of this article. In this article we are going to delve into the study of hurricanes and their unique characteristic features and abilities. A hurricane is a powerful and destructive tropical cyclone characterized by strong winds, heavy rainfall, and a distinct circular cloud pattern. It is a natural weather phenomenon that typically forms over warm ocean waters near the equator. Hurricanes are known by different names in various parts of the world. In the North Atlantic Ocean and Northeast Pacific, they are called hurricanes, while in the Northwest Pacific, they are known as typhoons, and in the South Pacific and Indian Ocean, they are referred to as cyclones. Regardless of their name, hurricanes are among the most potent and potentially devastating natural disasters on Earth. A hurricane is a large-scale atmospheric system that originates over warm ocean waters, typically above 26.5 degrees Celsius, 80 degrees Fahrenheit. It begins as a tropical disturbance, which is a cluster of thunderstorms. As warm, moist air rises from the ocean's surface, it creates an area of low pressure. This low-pressure system allows more air to rush in, forming powerful winds that rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. As the system gains strength, it develops into a tropical depression, which is characterized by sustained winds of up to 38 miles per hour, 61 kilometers per hour. If the winds continue to intensify and reach speeds of 39 to 73 miles per hour, 63 to 118 kilometers per hour, it becomes a tropical storm and receives a name. Finally, if the sustained winds exceed 74 miles per hour, 119 kilometers per hour, the system becomes a hurricane. The eye of a hurricane is a relatively calm and clear area at the center of the storm. Surrounding the eye is the eye wall, which consists of intense thunderstorms where the strongest winds and heaviest rainfall occur. The eye wall is responsible for the most severe damage caused by the hurricane. The Saffir-Simpson hurricane wind scale is commonly used to classify hurricanes into categories based on their maximum sustained wind speeds. It ranges from Category 1, which has winds between 74 and 95 miles per hour, 119 and 153 kilometers per hour, to Category 5, with winds exceeding 157 miles per hour, 252 kilometers per hour. Hurricanes can have significant impacts, including strong winds capable of damaging buildings, storm surges that cause coastal flooding, heavy rainfall leading to flash floods, and the potential for tornadoes. They can cause extensive damage to infrastructure, disrupt transportation and utilities, and pose a significant threat to human lives. Understanding the formation and characteristics of hurricanes is crucial for meteorologists to track and forecast these storms, allowing authorities to issue timely warnings and enabling communities to take necessary precautions to mitigate risks and protect lives and property. Hurricanes, also known as tropical cyclones, are formed through a combination of warm ocean waters, moisture, and specific atmospheric conditions. The process of hurricane formation typically involves several key steps. Warm ocean waters. Hurricanes form over warm ocean waters with temperatures above 26.5 degrees Celsius, 80 degrees Fahrenheit. The warm water provides the necessary energy for the storm to develop and intensify. Low pressure system. A disturbance, often in the form of a tropical wave or tropical disturbance, initiates the formation of a hurricane. These disturbances are areas of unsettled weather with clusters of thunderstorms. Coriolis effect. As the disturbance moves across the ocean, the rotation of the Earth causes the air to deflect, creating the Coriolis effect. The Coriolis effect is essential for the development of the cyclonic, rotating, motion in the storm. However, this effect becomes significant only at a certain distance from the equator, so hurricanes typically form between 5 and 20 degrees latitude. Organization and rotation. If the disturbance persists and environmental conditions are favorable, the system begins to organize and develop a rotating circulation. As the warm, moist air near the surface rises, it creates an area of low pressure, allowing more air to rush in from surrounding areas. This inflow of air starts to rotate due to the Coriolis effect. Formation of a tropical depression. As the rotation becomes more defined and sustained, the system transitions into a tropical depression. It is characterized by a closed circulation and maximum sustained winds below 39 miles per hour, 63 kilometers per hour. Tropical storm formation. If the tropical depression continues to strengthen, with sustained winds between 39 and 73 miles per hour, 63 and 118 kilometers per hour, it is upgraded to a tropical storm. At this stage, the system receives a name. Hurricane development. If the tropical storm's sustained winds exceed 74 miles per hour, 119 kilometers per hour, it becomes a hurricane. The storm's central region, known as the eye, becomes more defined, surrounded by a ring of intense thunderstorms called the eye wall. The eye wall is where the strongest winds and heaviest rainfall occur. Once a hurricane forms, it can continue to strengthen or weaken depending on various factors such as sea surface temperatures, atmospheric moisture, wind shear, and interactions with landmasses. These factors can influence the intensity and track of the hurricane. Understanding the formation of hurricanes is crucial for meteorologists and forecasters to track and predict their paths and intensities. This knowledge helps in issuing timely warnings, enabling communities to prepare and take necessary precautions to minimize the potential impacts of these powerful storms. The terms hurricane, typhoon, and cyclone refer to the same type of weather phenomenon, which is a tropical cyclone. The primary difference lies in the region where they occur. Here's a breakdown of the distinctions. Hurricane. The term, hurricane, is commonly used in the Atlantic Ocean and the northeastern Pacific Ocean, specifically the region around North America. Hurricanes in this area are characterized by strong winds circulating counterclockwise. Typhoon. The term, typhoon, is used to describe tropical cyclones in the northwestern Pacific Ocean. Typhoons are similar to hurricanes but occur in the western Pacific, affecting countries like Japan, China, and the Philippines. They also feature strong winds rotating counterclockwise. Cyclone. The term, cyclone, refers to tropical cyclones in the South Pacific Ocean and the Indian Ocean. Cyclones generally occur near countries such as Australia, India, and Madagascar. Unlike hurricanes and typhoons, cyclones rotate clockwise in the southern hemisphere and counterclockwise in the northern hemisphere. It's important to note that although these terms have regional distinctions, the underlying meteorological processes and characteristics of hurricanes, typhoons, and cyclones are quite similar. They are all large-scale, low-pressure systems that form over warm ocean waters and exhibit circular wind patterns. The primary factor that sets them apart is the specific geographic location in which they occur. Ultimately, the use of different terms for these tropical cyclones is primarily a matter of regional convention rather than fundamental differences in the storms themselves. The Saffir-Simpson hurricane wind scale is used to classify hurricanes into 5 categories based on their maximum sustained wind speeds. The categories are as follows. Category 1. A Category 1 hurricane has maximum sustained winds between 74 and 95 miles per hour, 119 and 153 kilometers per hour. These hurricanes are considered to be relatively weak, but they can still cause damage to buildings, trees, and power lines. Category 2. Category 2 hurricanes have maximum sustained winds between 96 and 110 miles per hour, 154 and 177 kilometers per hour. They are stronger than Category 1 hurricanes and pose a greater risk of damage. These hurricanes can cause extensive property damage and may result in power outages and localized flooding. Category 3. Category 3 hurricanes are major hurricanes with maximum sustained winds between 111 and 129 miles per hour, 178 and 208 kilometers per hour. They are characterized by significant damage potential. These hurricanes can cause extensive structural damage, uproot trees, and result in widespread power outages. They often bring dangerous storm surges that can flood coastal areas. Category 4. Category 4 hurricanes have maximum sustained winds between 130 and 156 miles per hour, 209 and 251 kilometers per hour. They are considered extremely dangerous and have the potential to cause catastrophic damage. These hurricanes can destroy homes and infrastructure, cause widespread power outages for weeks, and result in life-threatening storm surges and inland flooding. Category 5. Category 5 hurricanes are the strongest and most severe hurricanes on the Saffir-Simpson scale. They have maximum sustained winds exceeding 157 miles per hour, 252 kilometers per hour. Category 5 hurricanes can cause catastrophic damage, with the potential to completely destroy buildings, uproot trees, and cause widespread power outages. They generate life-threatening storm surges and produce significant inland flooding. The determination of a hurricane's category is based on its maximum sustained wind speed, which is the highest average wind speed observed over a 1-minute period near the center of the storm. Other factors, such as storm surge potential, rainfall, and overall impact, are also considered when assessing the severity of a hurricane. The Saffir-Simpson hurricane wind scale provides a standardized way to communicate the potential impacts of hurricanes to the public and aid in decision-making for preparedness and response efforts. Hurricanes typically occur in specific regions around the world known for their warm ocean waters and favorable atmospheric conditions. The primary areas where hurricanes are most common include Atlantic Ocean. Hurricanes in the Atlantic Ocean, also known as Atlantic hurricanes, typically form in the tropical and subtropical regions of the Atlantic Basin. They primarily affect the Caribbean, the Gulf of Mexico, and the eastern coastlines of North America, including the United States and Canada. Northeast Pacific Ocean. The Northeast Pacific Ocean is another active region for hurricanes. Storms in this area are referred to as Pacific hurricanes or Eastern Pacific hurricanes. They form off the western coast of Mexico and can affect Central America and the southwestern United States. Northwest Pacific Ocean. The Northwest Pacific Ocean is known for being the most active basin for tropical cyclones. Here, they are called typhoons. This region includes countries such as Japan, China, Taiwan, the Philippines, and other neighboring nations. South Pacific Ocean. The South Pacific Ocean experiences tropical cyclones known as cyclones. They affect islands and coastal areas in the South Pacific, including countries like Fiji, Vanuatu, New Caledonia, and Tonga. Indian Ocean. The Indian Ocean is another region prone to tropical cyclones known as cyclones. They affect countries along the coasts of India, Sri Lanka, Bangladesh, Myanmar, and the islands of the Indian Ocean, including Mauritius and Madagascar. It's important to note that while hurricanes are more common in these regions, they can occasionally occur outside of these areas. For example, rare occurrences of hurricanes have been observed in the South Atlantic Ocean and the Arabian Sea. The specific geographical location and local atmospheric conditions greatly influence the formation and tracks of hurricanes. Understanding the typical regions where hurricanes occur is crucial for preparedness, response, and planning measures to mitigate the potential impacts of these powerful storms. A hurricane is a complex weather system with several key components. The main components of a hurricane include eye. The eye is a relatively calm and clear area at the center of the hurricane. It is typically circular in shape and ranges in size from a few miles to tens of miles. The eye is characterized by light winds, clear skies, and sometimes even sunshine. The presence of the eye is a distinct feature of hurricanes. Eye wall. Surrounding the eye is the eye wall, which is a ring of intense thunderstorms. The eye wall is where the most severe weather conditions occur within the hurricane. It consists of strong updrafts and heavy rainfall, accompanied by the strongest winds of the storm. The eye wall is responsible for the most significant damage associated with hurricanes. Rain bands. Spiral bands of clouds and thunderstorms, known as rain bands, extend outward from the eyewall of the hurricane. These bands are curved and wrap around the center of the storm. Rain bands can be several hundred miles long and contain heavy rainfall, gusty winds, and occasional tornadoes. They contribute to the overall structure and size of the hurricane. Spiral outflow. Hurricanes have a characteristic pattern of spiral outflow at higher altitudes. This refers to the upper-level winds that flow outward from the center of the storm. It helps to ventilate the system and allow for the continued development and maintenance of the hurricane. Storm surge. One of the most destructive aspects of a hurricane is the storm surge. It occurs when the hurricane's strong winds push seawater toward the coast, resulting in a rapid rise in sea level. The combination of the storm surge and normal astronomical tides can lead to extensive coastal flooding, causing significant damage to coastal areas and infrastructure. Rainfall. Hurricanes are associated with heavy rainfall, especially in the outer rain bands and near the eyewall. The abundant moisture in the storm system results in torrential rainfall that can lead to flash floods and trigger landslides, exacerbating the impact of the hurricane. Wind field. Hurricanes have a well-defined circulation with strong winds. The wind field extends outward from the center of the storm and can cover a wide area. The strongest winds are typically found near the eyewall, but hurricane-force winds can extend far beyond the center, affecting a large portion of the storm's path. Understanding the different components of a hurricane is crucial for meteorologists and disaster management agencies to track and assess the intensity, size, and potential impacts of the storm. This knowledge helps in issuing timely warnings and taking necessary precautions to protect lives and property in vulnerable areas. The eyewall of a hurricane is a ring-shaped region surrounding the eye, located at the center of the storm. It is an area of intense thunderstorms and is considered the most active and destructive part of a hurricane. The eyewall is characterized by several distinct features. Strongest winds. The eyewall contains the strongest winds within a hurricane. The winds in this region are typically the most powerful and can reach their maximum speeds. These winds spiral inward and upward in the eyewall, creating a wall of rotating and violent air. Intense thunderstorms. The eyewall consists of a band of deep convective thunderstorms. These thunderstorms are tall, towering vertically into the atmosphere. They are associated with heavy rainfall, thunder, lightning, and intense updrafts. The updrafts in the eyewall contribute to the continuous development and intensification of the hurricane. Heavy rainfall. The eyewall is also responsible for producing some of the heaviest rainfall within a hurricane. The intense thunderstorms in this region generate copious amounts of precipitation. This heavy rainfall contributes to the overall precipitation associated with the storm and can lead to significant flooding, especially in coastal areas. Tornadoes. The eyewall is often associated with the formation of tornadoes. The intense rotation and instability within the eyewall can trigger the development of tornadoes in some cases. These tornadoes tend to be brief and small-scale but can cause additional damage within the larger hurricane system. It's important to note that the eyewall serves as a boundary between the calm and relatively clear eye of the hurricane and the outer regions of the storm, which often have weaker winds and less intense precipitation. While the eyewall is a highly active and dangerous region, the eye itself provides a temporary respite from the storm's severe weather conditions. Understanding the characteristics and behavior of the eyewall is crucial for assessing the intensity and potential impacts of a hurricane. Meteorologists closely monitor the eyewall to track changes in wind speeds, rainfall rates, and tornado activity, which helps in issuing accurate forecasts and warnings to mitigate the risks associated with hurricanes. Hurricanes are named through a system established by the World Meteorological Organization (WMO), an agency of the United Nations. The WMO maintains rotating lists of names for tropical cyclones in different ocean basins around the world. The naming process involves the following key points. Regional responsibility. Different meteorological agencies or centers are responsible for naming tropical cyclones in their respective regions. For example, the National Hurricane Center, NHC, in the United States is responsible for naming hurricanes in the Atlantic Basin, including the Caribbean Sea and the Gulf of Mexico. Other regional agencies or centers have similar responsibilities for their respective areas. Lists of names. Each region maintains a predetermined list of names that are used in a sequential and rotating manner. The lists typically consist of both male and female names, often alternating between the two. The names are chosen to be easily recognizable, pronounceable, and culturally sensitive, reflecting the diverse regions affected by tropical cyclones. Retired names. If a hurricane causes significant damage, loss of life, or is otherwise deemed memorable or notorious, its name may be retired. Retired names are no longer used for future storms. This is done to honor the victims and to avoid confusion or insensitivity associated with reusing the name in the future. The decision to retire a name is made by the WMO in consultation with the affected region. Yearly updates. The lists of names are updated and reviewed periodically by the WMO. Typically, new names are added to replace retired names or if changes in naming conventions are warranted. The updated lists ensure a continuous supply of names for upcoming hurricane seasons. During the hurricane season, which varies by region but typically spans from June to November, storms that reach a certain intensity and meet specific criteria are named consecutively from the predetermined list. The purpose of naming hurricanes is to facilitate clear communication and awareness among meteorologists, emergency management agencies, media outlets, and the general public. By assigning names to hurricanes, it becomes easier to track and discuss individual storms, issue warnings and advisories, and differentiate between multiple systems occurring simultaneously or within a short period of time. This aids in enhancing public safety and preparedness efforts during hurricane events. Hurricanes are tracked and monitored through a combination of ground-based and satellite-based observations, meteorological models, and specialized aircraft. Here are the main methods used for tracking and monitoring hurricanes. Weather satellites. Satellites equipped with various instruments, such as visible and infrared imagers and microwave sensors, provide continuous observations of hurricanes from space. These satellites capture images, measure cloud temperatures, detect precipitation patterns, and track the movement of the storm. Satellite data helps in determining the size, structure, and intensity of hurricanes, as well as their overall track and behavior. Weather radar. Ground-based weather radar systems, located in coastal areas and islands, are used to monitor hurricanes. Radar can provide detailed information about the storm's structure, precipitation patterns, and even identify features like rainbands and eye walls. Radar data helps meteorologists track the position, intensity, and movement of a hurricane in real time. Aircraft reconnaissance. Specialized aircraft, such as Hurricane Hunter aircraft, are deployed to fly directly into hurricanes to gather critical data. These aircraft are equipped with instruments that measure temperature, humidity, wind speed, and pressure. The data collected from these flights helps in determining the storm's strength, structure, and size. It also provides valuable information for improving hurricane forecasting models. Buoy and ship observations. Weather buoys and ships stationed in the vicinity of a hurricane provide important data on sea surface temperatures, wind speed, wave height, atmospheric pressure, and other meteorological parameters. These observations, combined with satellite and radar data, help in validating and refining hurricane forecasts. Meteorological models. Advanced computer models specifically designed for hurricane forecasting are used to simulate and predict the behavior of hurricanes. These models utilize observed data, including satellite and radar measurements, to make predictions about a storm's future track, intensity, and impacts. Model outputs are continuously analyzed and adjusted as new data becomes available, improving the accuracy of forecasts. Data assimilation. Data assimilation techniques are used to integrate various observations into meteorological models. This process involves combining measurements from different sources, such as satellites, radar, aircraft, and ground-based instruments, to provide a more complete picture of the hurricane's current state. Data assimilation helps improve the accuracy of hurricane forecasts. Meteorologists and forecasters at national meteorological agencies, such as the National Hurricane Center in the United States, closely monitor these observations and use the data to issue regular updates, forecasts, and warnings regarding the track, intensity, and potential impacts of hurricanes. This information is crucial for emergency management officials, governments, and the public to make informed decisions and take appropriate actions to protect lives and property in areas at risk from hurricanes. The relationship between climate change and hurricanes is a complex topic that is still being actively studied by scientists. While it is challenging to attribute individual hurricanes directly to climate change, there is growing evidence that climate change is influencing certain aspects of hurricanes. Here are some key factors. Sea surface temperature. Warmer ocean temperatures provide the energy that fuels hurricanes. As global temperatures rise due to climate change, it leads to increased sea surface temperatures. Warmer oceans can provide more favorable conditions for hurricane development and intensification. Higher sea surface temperatures may contribute to an increase in the frequency and intensity of hurricanes. Atmospheric moisture. A warmer atmosphere can hold more moisture. As the climate warms, there is an increase in the amount of water vapor in the atmosphere. This can result in more intense rainfall within hurricanes, potentially leading to increased rainfall rates and the risk of flooding. Storm intensity. Some studies suggest that climate change may lead to a greater proportion of the strongest hurricanes, Category 4 and 5, in the future. The exact relationship between climate change and hurricane intensity is an active area of research, and further studies are needed to understand the potential impacts. Storm surge. Rising sea levels, which are associated with climate change, can exacerbate the impact of storm surge during hurricanes. Higher sea levels mean that storm surges can penetrate further inland, leading to increased coastal flooding and damage. Hurricane tracks. Climate change may also influence the tracks of hurricanes. However, current research does not provide a clear consensus on the future changes in hurricane tracks. It is possible that changes in atmospheric circulation patterns influenced by climate change could affect the paths that hurricanes take. It's important to note that while there is evidence of some aspects of hurricanes being influenced by climate change, other factors, such as natural climate variability, still play a significant role. Additionally, it is challenging to separate the influence of climate change from other factors that affect hurricanes, making attribution complex. Overall, the impact of climate change on hurricanes is an active area of research, and scientists continue to study and refine our understanding of these relationships. The Intergovernmental Panel on Climate Change, IPCC, and other scientific organizations regularly assess the current state of knowledge on climate change and extreme weather events, including hurricanes. Hurricanes can have significant economic impacts on affected regions. The exact economic consequences vary depending on factors such as the intensity of the hurricane, the size of the affected area, the vulnerability of infrastructure, and the level of preparedness. Here are some common economic impacts of hurricanes. Property damage. Hurricanes can cause extensive damage to residential, commercial, and infrastructure properties. High winds, storm surge, and heavy rainfall can result in the destruction or severe damage of buildings, roads, bridges, power lines, and other critical infrastructure. The cost of repairing or rebuilding damaged structures can be substantial. Business disruption. Hurricanes can disrupt economic activity for days, weeks, or even months. Businesses may need to close temporarily or permanently due to damage or loss of customers. Industries such as tourism, agriculture, and fishing, which rely on stable conditions and infrastructure, can be particularly affected. The disruption of supply chains and transportation networks can also impact businesses across wider regions.
Loss of income and jobs. As businesses close or reduce operations, workers may experience loss of income or even job loss. This can have long-lasting effects on individuals, families, and local economies.
Sectors directly impacted by hurricanes, such as tourism and hospitality, may experience a significant decline in employment during and after the storm. Emergency and recovery costs. Hurricanes often require significant financial resources for emergency response and recovery efforts.
Governments at various levels must allocate funds for evacuations, search and rescue operations, emergency shelters, debris removal, and infrastructure repairs. These costs can place a strain on public budgets and lead to long-term fiscal impacts.
Insurance and reinsurance costs. Insured losses resulting from hurricanes can be substantial.
Insurance companies and reinsurance companies, which provide insurance for insurance companies, may face significant payouts due to property damage and business interruption claims. These costs can impact insurance premiums and the availability of coverage in hurricane-prone areas.
Public services and infrastructure. Hurricanes can strain public services, such as healthcare, emergency response, and public utilities. Hospitals may face increased demand for medical services, while utilities may need to restore power and water supply to affected areas. The costs associated with restoring and maintaining public services and infrastructure can be substantial.
Tourism and local economies. Regions heavily dependent on tourism can suffer a significant blow from hurricanes.
The disruption of tourist activities, damage to hotels and resorts, and negative media coverage can lead to a decline in tourism and subsequent loss of revenue for local businesses and communities. It's worth noting that the economic impacts of hurricanes can extend beyond the immediate affected area. Supply chain disruptions, increased costs of goods and services, and shifts in labor markets can have ripple effects across broader regions and even globally. Efforts to mitigate the economic impacts of hurricanes include disaster preparedness and planning, building resilient infrastructure, improving early warning systems, and investing in insurance and risk management strategies. These measures aim to reduce vulnerability, enhance recovery, and promote long-term economic stability in hurricane-prone regions. In conclusion, hurricanes have profound economic impacts on the regions they affect.
These powerful storms can cause extensive property damage, disrupt businesses and industries, lead to loss of income and jobs, and impose significant financial burdens on governments and insurance providers. The destruction of infrastructure, disruptions to supply chains, and the strain on public services further contribute to the economic toll. The economic consequences of hurricanes extend beyond the immediate affected areas, affecting broader regions and even global markets. Sectors like tourism, agriculture, and transportation can experience long-lasting setbacks. Furthermore, the costs associated with emergency response, recovery, and rebuilding place a burden on public budgets and resources. Addressing the economic impacts of hurricanes requires a comprehensive approach. This includes investing in disaster preparedness, building resilient infrastructure, improving early warning systems, and implementing effective insurance and risk management strategies. Collaborative efforts among governments, businesses, communities, and international organizations are essential to reduce vulnerability, enhance recovery capabilities, and promote long-term economic stability in hurricane-prone regions. Understanding the economic impacts of hurricanes helps in developing strategies to mitigate risks, allocate resources efficiently, and support affected communities.
It also highlights the importance of climate resilience and adaptation measures in the face of a changing climate. By investing in resilience, preparedness, and sustainable development, societies can better withstand the economic shocks caused by hurricanes and build a more resilient future. Thanks for